Okay, cool. We are live. So, hi everybody. Welcome to the Diffusion Architecture YouTube channel. My name is Daniel Escobar, and I'll be hosting this session with FIRAS SAFIEDDINE. So, FIRAS, thank you for joining us. We're excited to have you here and looking forward to your presentation and conversation. So, a little bit introduction about FIRAS. He has a very interesting background. He works at the intersection of architecture, neuroscience, urban planning, and metaverse, among other things. Uh, and Firas is a spatial design practitioner whose work spans architecture, urbanism, design, ecology, and neurotechnology. He coined the term electrical ecologies and aims at designing the first architecture brain implant. So Firas, thank you for
Thanks.
being here, and go ahead. The floor is yours.
Well, thanks for the introduction and thanks for doing what you are doing. So that's awesome. And I'll just start, I think, just not wasting time. Let me share my screen and we dive deep in. Okay, so I have put together a bunch of slides to kind of like steer this a bit in a way that I think would be productive. Starting from these main questions, right? So the first question is, who are we in the sense of like, can we still be just like architects as we were 30 years ago, or 50 years ago, or 100 years ago, or 1,000 years ago? And then the second question is, what are we doing? Because I don't think we're still doing architecture that what architecture was before as well, right? We're doing a lot of different things. And then the when is super important in how it drives this in the sense of understanding our current technosphere. And then finally on how we do it. Because I think there is where most of my brain energy, like I'm just allocating that there because I think that AI can design a lot of cool stuff. So as designers, probably the our job now is not to design the next cool building, it's to design the next cool practice. So the question of how is the practice model of the future looks like is what I'm kind of trying to figure out. So I'm going to walk you a bit through some of my interests and how things kind of came together, starting from the very beginnings of why I got into neuroscience, and then how this shaped a bit of the research, and then how this became what I'm teaching now, and then other things we're doing. So I've been always fascinated with the idea of the body, the human skin, the interface theory, and so on. So here I was just thinking, how can the human skin become a future interface where technology can be embedded, and then the human skin can become a display. So it grows that ability as we evolve. And again, thinking about what we're doing, the references for what we have been doing as kind of, let's call it interdisciplinary practitioners, is diving deep within architecture, technology, philosophy, some psychology over there, some other programming over there, computer science, physical computing, and so on. So all these kind of things come together to form what we are doing. So this was actually my reference list for my thesis project. It's like getting bits and pieces from everywhere. And this whole thing started when I understood one thing. Then with the technologies we have today, we have the capacity to design not for the user, which has been the narrative for the last 100 years, but to design the user straight away. And to do that, we'll have to interface with our biology. And we can do that through different ways, but there are two different questions that shaped my research after that, which are, what if buildings knew who we are, right? Could communicate with us and could interface with our biology, with our brains, with our heart rate, with all these things. And then what if we could try spaces before we buy them? In the sense of how can not just try them as in see them as renders, but actually experience them. So having them kind of come out to us and understand how we would feel being in these spaces, not how they look. And again, a very basic timeline of how we understand the history of architecture, from basically looking at the architectural interface or the medium that has been physical objects like wood and stone to paper when architecture became more about drawing, and then now we see screens, and then later we'll do brains, I think. So we can talk a lot about this probably afterwards. So I was just designing these devices in the beginning, thinking on how can we do a research tool for architects to interface that, quantify humans and spaces. And then this went beyond just research in the classroom, right? Going to the urban scale. So this is an experiment we just did some months ago, where we went to measure how we actually feel in urban environments and validating some urban interventions that were done at the scale of the city. So here we went to understand the relationships between pedestrian streets and car streets, and then what is the impact that these two could have on our emotions. And then, well, this stems from another research which we're doing eye tracking and facial expression to understand how can users be part of a workflow together with AI to produce better healthcare environments. And then this became part of what we're teaching now at IAC, where we're trying to bridge VR, AI, and neuroscience, and then see how we can play with that. So that is one of the students' work where we understand a workflow that is both embedded in these technologies, but then works in a kind of a feedback loop system where the AI and the person are both in kind of permanent mutation between each other. But one thing we can discuss as well is the quantification of the human experience and the space. So we're trying to quantify spatial, like the space through spatial metrics that we're dissecting here, and then to quantify the human experience through human metrics. But to do this, we're exploring a lot of different AI models that you probably have played with. And then we're using this as generative models, and then we're evaluating that using biosensing, and then seeing how that can feed the design, and then tweaking these systems, and then having them experienced by people. So that was more of the foundation to where neuroscience comes in and what we're doing. But then I'd like to straight away jump to the next part, which is how we practice, because I think it comes hand in hand and it's super important. And then both things feed into each other. I'm gonna run you through several projects that have different scales in media, and then that would lead us to the last question of what we are practicing. So I'm gonna show you some projects that we're doing. This one was like a unicorn headquarter or like a mega structure in China, Chengdu, where we have we thought that the answer for something that is like at a territorial scale would come in something that is big enough. So we were working at that scale, which is a bit more than architecture, but a bit less than urban, right? And then beyond that, we have been working in a lot of architectural projects, but I wanted to show that one because this is a very interesting project because it was in two phases. And the first phase, AI was still doing rendering, but it was a bit primitive. So we were rendering from these Rhino screenshots to these AI renders, and then from this shot to this shot. But then when phase two came in, right, AI had already within 2 months evolved to a much interesting tool where we were creating renders that looked more like this, right? And then this is very interesting because we never see things evolve at that speed. Usually technology is either much faster or much slower. And then in this project, it was a very happy moment because as we were doing the project where you have no time when you're doing 5 competitions, this was like super handy. So we were doing renders at that style literally 2 months after this, just because the technology has evolved that fast. So from architecture, I'll go to products and objects where we have been doing a lot of things, but I want to show this because it intersects with what we believe at the urban scale when we talk about ecological urbanism. This was a skin which was bioreceptive and absorbed CO2 from the air, and then we managed to 3D print it and display it at the Magdalena Palace. And then again, we had to collaborate with Machina, which was the company which was printing, and then they use different material technology, and then this whole thing kind of comes together between research design. How is the impact of this at the urban scale and back and forth? And then within interactive media, we do a lot of things, but these are all kind of interactive architecture, or call them new media or visual or audiovisual installations. But they always start from the research, and they're always a workflow and a project that translates into a visual in the end. So this is the last one we've been working on, which is at the scale of the territory and using AI to kind of understand data visualizations that we were doing, be it wildlife flows within the territory, railway networks, NDVIs, and so on and so forth. And then finally, a lot of the metaverse things we're doing, from designing worlds to cities, and finally just spaces that are catered to actual businesses that exist in the real world. So that's an Edward Biner space. Um, we're working with a lot of clients. This is like a standard charter, geo, and so on and so on. The list is very long. I just wanted to show that this can happen at various scales and this has utility, right? And this is probably one of the dearest metaverse projects we've been working on, which is a real life project which has this kind of intersection where real students in Brooklyn are coming into these wooden containers, and then amazing teachers are coming in, and we're kind of contributing through our metaverse experience and designing these VR and AR environments where teachers can start to build their curriculum there. Students can access these technologies, although they're underprivileged within this spot where we're doing the project, they have access to that technology, right? And then everybody is just contributing however they could and so on. So it's a super cool project. And the reason why it's part of the dearest is that it connects real world, virtual, and something in between. And we're doing a lot of things. The kids are learning how to design these environments. We're doing it for them. We're doing it back and forth with the teachers and so on and so forth. And then again, all this is to kind of come to this. What should we do next, right? And the question which we always get, like, and now what? Um, I think, of course, I mean, like design runs in our blood. I know that, and I love it. But I think one thing I'm kind of like trying to add on what we have been doing or what I've been doing for a while is try to think, what does the practice of the future look like? What are we practicing, and how do we do that? Because I came to the realization that probably we're not architects anymore in the sense of what architecture was. Architecture evolves and we evolve with it. We can still be calling ourselves architects, and that's great. But I think we should start to think about ourselves as spatial designers, because that kind of is an umbrella term for a lot of things. And that's how at Spatial Forces we're trying to, structure that or conceptualize it in a certain framework where we work in units. So we have been doing think tank where we do research, urbanism where we do urbanism, architecture, objects, experience where we do metaverse and extended reality and all these kind of things, and finally media where is media arts. And practicing all these things is what could be spatial design, right? But then as well, how do you practice when you do something like this? You need a lot of bandwidth and so on. So we are developing different models where we do, well, we do a lot of partnership on demand models. Because again, we are at a point of time where personal skills and personal profiles are very important. And then what that means is that intellectual property is becoming more important. Ownership of that property is important, where you keep your stuff and so on. So we're trying to find ways to practice where the individual is celebrated, and then there's a framework where the individual's contribution can fit within a larger scale. So we're thinking about things of ownership, authorship. Is there a difference between them? How do we do collective authorship? Because collective ownership is simple and so on. So yeah, that is just like a quick fire of what we've been up to, kind of, and then I'll leave it for you.
Okay, awesome. Thank you, Firàs, for that presentation. That was really cool. It's awesome to see the wide range of projects that you're taking on over the last few years and your train of research that you're pursuing. So let's get a little bit into a little bit of your background, right? Because you did study in Barcelona, right? And that there's an interesting I guess like seeing going on there, like a EAC and things like that, where it's like a little bit exploratory in architecture themes. So maybe tell us a little bit about your background and how you got there.
Sure. I think one of the things is that it's very hard to get to IAC by mistake. I mean, you have to belong to go there, right? It's one of these
Yeah.
places where it has a lot of character, and you know where you're going. So going there was one of the most important things kind of I've done, because then you meet awesome people, right, that are doing awesome things, and that's what we do. We just do cool stuff with cool people. That's what we want, right? So that shaped a lot. And then Barcelona itself, there's a really nice scene of people who are doing stuff. There's a very nice maker scene. There's a lot of design stuff happening. So that shaped a lot, and that's where I started doing everything. And what was interesting is that during my studies at IAC, I was very much into research as much as I was into tech stuff, right? And then I started to do a lot of smaller scale things like installations and audiovisuals and interactive stuff. But then straight after IAC, what I ended up doing was more at the urban scale, so like the complete opposite, right? And then that was interesting because I went through urbanism for something that's around like 3, 4, 5 years, doing really big projects in China and Africa and different kinds of parts of the world. And then that kind of schizophrenia was super cool because then you're seeing both, you're touching both. One is very physical and executable very quickly because you design an installation in a festival and then you go and build it there in 2 months, right? But then you spend like several months working on an urban plan that probably will never be executed as you drew it, right? So it was a really nice back and forth there. The people you meet, and then everything in between. So from there, we were doing a lot of things in between, and then things started to come together. Where probably 2, 3 years ago, the whole metaverse stuff started, and then we realized that, oh, hey, we have the skills to do that, right? Like we architects have been trained in a lot of different spaces, but if you look at it closely, we actually have what it takes to do that, right? Obviously, we need collaboration of a lot of other expertise, but we have what it takes to do this as well. So we started to do that too, right? And then from there, this like the puzzle started to come together.
Yeah. And what you say or what you describe like the architect is like it's a spatial designer, right? And I think it lets you dip your toes and kind of like all these other disciplines in some way, not limited to like physical buildings in itself, but just like the idea of generating concepts and generating like spatial concepts that can be immersive. That's really interesting. Now, how do you approach the metaverse, or how do you see it? Like you kind of show like a really nice project in Brooklyn, but how do you see it like as a tool that can help either like students that are studying architecture that allows them to kind of like dive into these new technologies or immersive technologies that maybe like a few years back were in this commonplace? And how do you see it like helping like education of students as well?
Yeah, look, let's linger a bit on the first one because for me, they're not different disciplines. It's the same one. So,
Hmm.
and this depends on how you define architecture, right? Because if you define architecture as buildings, then like all this doesn't make sense. You just go and design
Mm.
buildings, right? But for me, architecture is not buildings, and that's why it makes sense to be doing what I'm doing. So, for me, architecture is literally like I always try to define architecture because that's what we do all the time. But for me, it's literally the cultural discourse where we consume and produce interiorities, right? So if you define architecture like this, then literally whenever you do that, you're doing architecture. So for me, all of these things we do are architecture. And then not to get into this conversation of this architecture or not, okay, like,
Yeah, yeah.
okay, let's call it spatial design and then everyone is happy, right? Because again, like if you look at all what we're doing, the common denominator between that is that they're all spatial, and they all think about. I mean, they all deal with the thing we're designing and in the spatial context. And then, as architects, we're always creating worlds, and worlds always come within worlds, right? So if you're doing worlds and worlds within worlds, then even if you're doing a metaverse, if you're doing a building, if you're doing a stage set, if you're doing an installation, you're always thinking that as long as that's what's in your mind, right?
Mm.
So for me, they're not different disciplines. I just see them as like, different scales in media. And that's what I always try to differentiate. So if we're doing, I mean, whenever I'm doing something, literally, we can work at the microcontroller scale, right? And we
Hmm.
can work at the territory scale. But sometimes, if you think about it, when you work at the territory scale, you're at the territory scale. But then sometimes when you work at the micro controller scale, you're at the territory scale as well. Because, for example, there's a project here which is called Smart Citizen, which is a sensing kit that you put in urban spaces, and then it
Hmm.
measures things like the temperature, humidity levels, noise, so on and so forth, right? I mean, this thing collects data from the whole territory. It's an Arduino
Hmm.
board, but then it has an impact on the territorial scale. So we need to start to understand that. And I think this is something that with the technologies we have, we can do it in a much more accessible way, I would say. And then to jump to the next point, the metaverse. For me, it's something that just was a natural transition in a way. I mean, it takes a lot of steps, but obviously, like most of us, have the modeling part kind of
Hmm.
there. we have kind of the spatial layout, we have the kind of spatial framing of human interaction, of social interactions. We work mostly in virtual, interfaces. We work with this kind of designing things in a computer. We render them with the visualizations and simulations and so on. So that kind of package is already there because in the end, again, like whenever we're doing this, we're doing a spatial framing for social interaction, for human interaction, for anything. So that's our part, and that's where we come in, I think, most efficiently, and as well because we have this kind of understanding of space that is part of what we study as well, right? And what we
Hmm.
practice. So that is something important, which is like proportions, scales, and so on. But then obviously there's the second part, which is what becomes very, very crucial, which is the game development part, or
Yeah.
whatever like that takes, from texturing to unwrapping to developing like interactions and then putting this in a game engine and then deploying this. And then there's the other part, right, where you have to put this on the internet, and then
Hmm.
that's another thing. But obviously nobody does everything. There's like some people who are developers and some people who are, you know engine artists and whatever. So it's very important that we understand where we can come in this, right, and then work on that, because that will lead us to start to talk with these other people, like a Unity developer, like someone who's a web developer, like a backender, whatever, and then start to understand their language, but then as well start to educate them on where we come in, and then having this whole loop come in, right? So that's about that. And then regarding education, I mean, this project has been one of my favorites, and it's because it had a real impact on real people.
Hmm.
But I mean, I can see two, three trends that are quite interesting. So the first one is gamification, right?
Yeah.
I mean, now you see all kids are on iPads and everyone is on their phone and so on. So the best way to learn is to play a game, because that's what our brains want, right? You want to play
Hmm.
around, then while you're playing you're learning. So that's the best curriculum, and this is something like the whole gamification thing is coming with a lot of what metaverse products are coming with as well. And then you have this kind of thing where you play to earn or learn to earn, or all these things. So you start to have tokenization within these, you start to have coins and points, and like a leaderboard and a community, and then who's doing better, and then you want to achieve and unlock new challenges, and then if you do that you get a different status within this. So like this whole Gen Z, Gen Alpha coming in
Hmm.
is shaping technology as well, as much as technology is shaping these people, because technology is, I mean, how we see now the internet is changing, and with the metaverse, the main consumers of these things are young people, and these young people who are now young are going to be the consumers and the people who have purchase power in 10 years or 20 years. These are going to be the main people driving the markets, right? So that's why every brand wants to be in Roblox now. That's why everyone selling anything wants to be in the metaverse, because
Yeah.
that's where you can grow your community that can actually buy your stuff in 10 years, if not now. So, I think the metaverse allows a lot of interesting things, mostly interaction between people and gamification that kind of really change how learning happens.
Yeah. No, that is cool. That makes so much sense in the sense that you're scaling. It's kind of like building like a new type of social media, but with games, right? That these people are kind of interacting in a more three-dimensional way.
Yeah.
Um, and Firas, one of the, I guess, like the interesting thing about like the whole metaverse and being able to develop these sort of 3D spaces on web-based platforms is kind of like the rise of the game engine, right? Where Unreal Engine is now essentially delivering like realistic visuals real time, and you see it now more and more that I guess clients in the even in the architecture space are expecting like game engine type presentations where you have like real time immersive experience of like whether it's like an urban plan or like a building. What are your thoughts on that, and like do you use that essentially for like your architecture projects as well?
So our last competition that we made in China was in a place called Pingchang, close to Shenzhen. Well, it's part of Shenzhen on the right side. And then it was the first. Like I've been part of more than 33 urban design competitions in China end of last year, so beginning of this, was the first time we were asked to actually deliver an Unreal Engine file, not only the animation, the file
Oh,
itself.
cool. Yeah.
Yeah, that is something. So this was the first time. It was not mandatory,
Hmm.
but it was the first time that this was part of the requirements to send like the whole Unreal Engine file, not just the video. Because usually what happens is that most offices outsource the animation, right? I know you can outsource the file as well, but asking for the file is interesting because I think this is like definitely a shift in how we practice. Beyond that, we are literally developing something similar to what you're saying, where people can visualize stuff inside a build that we did in Unreal Engine as well,
Hmm.
to see how their apartments look, to see how their buildings would look, to see how the spaces would look, and actually go inside and interact with them. So you can go into a space, change the colors of the wall, change the furniture, and so on as a client, and that's cool. So it's definitely coming in, but I know it's not related, but just to go back to the previous thing we said, graphics are not always important because
Hmm.
if you have, look, there are two things that drive the metaverse and this whole thing coming out. There's utility and there's experience. Um, Utility is, for me, is what matters. Not in terms of for me as a designer, but looking at the market, I see more value in utility at the moment than just good graphics. Because if you look at like the best platforms, they're not graphically amazing. I mean, if you look at Decentraland, if you look at Roblox, which is the big
Yeah.
guy, right? I mean, the graphics are way below what nice graphics could look like, right? And the reason why they're successful is that because they were able to actually create a platform that can drive community in and then
Mm.
can give community the utility it needs to stay there and do what it wants. And this comes at a cost, of course, of graphics and the other way around. I mean, you do cool graphics, but then you cannot do all the rest. You can argue that technology is going to become better and better, and then we can all have Unreal experiences, and this is going
Yeah.
to be super fast and whatever on mobile and so on. But yeah, I think like the access is somewhere there. Like we need to always look at, for me, as at least, utility is king for sure. When we do any metaverse experience, very few brands are interested to just have a cool experience where people can just jump in. They want places where people can log in, people have the wallets connected, people have the capacity to buy stuff there. They want to have a lot of avatars come in. They
Mhm.
want things customizable, and then they're ready to compromise graphics to get numbers, right? Because at the end,
Mhm.
it's a business. They want to sell stuff, they want to get people in, and so on and so forth. So from that perspective, we have been working with lo-fi and hi-fi platforms. We have been building on platforms like Decentraland and Roblox and Geometry, and then we've been building on platforms like Unreal and I mean engines like Unreal and Unity. And we know the difference. We've seen clients who want both. But if you look at budgets, if you look at numbers, the lo-fi wins, right? For a
Yeah.
reason. So yeah, I think in our practice as designers, obviously we want to sell cool graphics where utility is not so important in terms of the graphics themselves. They just, show the idea and the concept and stuff. But once we get to like metaverse stuff, no, I think utility is still more important than graphics.
Yeah, cool. And you mentioned something about like community building.
Oh yeah.
Now I'm curious, like if, for example, like have you thought of if it's like if it would be useful, for example, like when if you're doing like developments or something in some area, you invite like people within the community to engage within like kind of like a metaverse like platform, and discuss the design and provide kind of like feedback in a more immersive way versus just kind of like traditional presentations or some sort of survey and things of that nature.
Yeah, so we've done this for sure, mainly at the urban scale. But let me just refer you to one thing. So at that scale, I think things like the blockchain become more interesting because then you can get people who don't have access to metaverse stuff on chain easily just through their phone. And then they can do DAOs, they can vote, they can get tokens, they can, so you can do a lot of interesting things using the blockchain without having to be on the metaverse fully in terms of like the whole immersive experience stuff. Um, so regarding involving community, I meant it in a different. Like, I mean, we obviously involve them in design, but what's happened? Like, there's a huge shift now, and probably most of us have been noticing this, where people want to follow people. people want to kind of associate with human beings. Now a lot of us, they have their own servers, their own Instagram pages. Then like, we become a creator, and then we have our community of followers, right? And then
Yeah.
this is what a lot of us are been doing. So instead of having like 12 big architect names that are super famous, now we have probably 12,000 that are less famous, but each is more famous in their own community of 5,000 people, 50,000 people, 100,000 people, whatever, right? So this whole thing of community comes within the content creation revolution, what we could call it, right? So what we have been seeing in the last 10 years is that content creation has been more accessible, not only to produce stuff, but to publish stuff and stay and keep ownership, right? So
Yeah.
now as a creator, you can do your stuff, post it on whatever platform you want to post it, share it on Instagram, share it on Twitter, share it on LinkedIn. Probably some people are live streaming their stuff as well on different platforms. And then like these platforms give you the channel to be available to different audiences. And then
Mhm.
these audiences will follow you because they get value out of what you're sharing, right? So this is what happens on Patreon in a very extreme way, but this can happen without people having to pay or you pay. The value is shared in an indirect way. So that's where I see a lot of the importance of communities happening. I mean, if you look at most of the NFTs sold, right? They're not sold
Yeah.
because they look pretty or they look bad or whatever. They are sold
Yeah.
because they either have a utility or they have a community behind them, right? And then that's important to understand because I mean, I was in a conference in Munich, met a super cool guy, and then probably he'd know him, Yatsu, and then he was saying, the in the next years with the blockchain and the metaverse coming in and the whole NFT stuff and whatever, it's going to be more important who produces a song than what the song is. So if Drake goes out and produces a void MP3 file, right? That's probably going to be more expensive than if I go produce an amazing song and put it online, right?
Yeah.
Not because
Yeah.
the other one sounds better, but it's just because it has more value. And it has more value because he has bigger community that he can
Yeah.
call to action and then do things. So I think this is where the shift in the space is happening, and this is what we're trying to promote as well within what we're doing as a practice. The So, for example, when we work, nobody's an employee, right? Everybody is a partner in any project we do, and
Hmm.
that's because, I mean, what's the vision, right? The best case scenario is that everybody of us, like all designers, become kind of their own practice, right? But then all of them have a framework to come together and practice at a larger scale, right?
Hmm.
So that's exactly what we're trying to go after. But because I think this is where things are going not having big companies that have 1,000 employees, but having these kind of clusters of individuals that are, distributed between these networks of cool people.
Yeah. That's super interesting. It is kind of more networked based in some
For
sense, right?
sure.
And now the community is worldwide, right? Or you can have like this kind of international based community that can work within that space.
Like we've been
Um,
practicing, like I mean, as Spatial Forces, we've been doing more than 3 years of practice. We've designed a lot of, I mean, only metaverse. We've designed more than 70 metaverse spaces, among all the urban whatever other stuff we're doing. And then since for the last 3 years and a half, we've been like every time somebody joins a server, and now we're like around 40 people on the server. So only
um,
only with this we've been 30, right? And then now you have this cluster of people that is there, and then some of this cluster is in another cluster, and then it's just like all these clusters of people who are doing their stuff, but
yeah.
these are people who kind of own their stuff as well. Like they have their own profiles, their own websites, they're doing their stuff, but then we come together to collaborate because you cannot do things on your own as well. It's the market doesn't allow you.
Yeah, yeah. Cool. And Firas, so you coined the term electrical ecologies, right?
Mhm.
Can you talk about that and what that means?
Sure. So probably most of people listening, or maybe not, they would know Timothy Morton. They would know dark ecologies, black ecology, and then that's a term that came in response to the Anthropocene, and as well understanding that all is nature. Just to put it in a nutshell, right? And then what I felt was a bit missing there was, okay, that's more of an observation, but then it's not operational in that sense. So and I was in a phase where I was trying to figure out this idea of the brain implant for architecture,
Hmm.
because where this comes from is, okay, let's do a very silly history class, right, in 20 seconds. So architecture started where people were actually building, right? So architects were actually building with wood and stone. So their medium for architecture was matter, in the sense of like the material they built with. Then this evolved and they discovered that, oh, hey, I can just do a drawing of a building and then somebody else can build it. Ah, nice. So then the medium for architecture became paper, not material.
Yeah.
And
Mm.
then after that, somebody came in and thought like, oh, instead of drawing the whole thing, I can just do a set of rules, right? And then like an IKEA kit, I can just give stuff. So that's like the birth of the indexical system. So instead of doing drawings, you do rules that produce these drawings that then somebody will build with material, right? So, and then this kind of thing went all the way to say, okay, so whenever technology evolves, we're stepping one step away from the building, and we're getting one step closer to architecture, in the sense of what the essence of architecture is, which is conceiving and producing interiorities, which can be done without having to touch the building itself, right?
Mm.
So if what architecture becomes is doing indexical systems or doing, like the whole codes, even you don't have to do like the system itself, you can just code it, right? And then like jumping all this thing, I was like, okay, where would architecture go? And what will be the second medium for architecture? And then if you project this long enough, it's like, okay, if I want to produce that experience, and that experience is produced in the brain, so the way to do architecture would be to stimulate certain circuitry in the brain to produce these
Huh.
experiences without the need
Okay.
for a building, right?
Yeah.
Um,
Going
so
to the
so
source.
yeah, exactly. So
Yeah.
that was the reasoning, and then that's where the idea of the architectural brain implant came in. But because then the question becomes how we design for the implant, because we know how to design for paper, we know how to design for matter, we know how to design
Oh,
for
yeah.
code, we know how to design for screens, but we don't know how to design for brain implants, right? So that is where the reasoning comes from. And then when you're doing this, you become aware that your brain as a neural system, neural system, right? I would call it a neural ecology. Okay, comes from a place where this was kind of not neural, right? So if you think about the world, things were first mineral, right? So there was only matter here, probably,
Mm-hmm.
and then from matter, biology emerged, because we think, I mean, for now we know that matter came, like the minerals came before biology, right? So there was some stardust there. And then the idea is, how does minerals become biology, right? And then if you look closer, the way that minerals can become biology is through manipulations in the electrical layer. So you have charged matter, and then you have electrical object, and then you have neural objects, and then you understand that there's no biology without electricity, right? And then if you want to take things all that way, you produce intelligence, and the prerequisite for intelligence is electricity. You cannot,
Yeah.
we don't know a lot of forms of intelligence that don't run on electricity, right? From humans to boards to computers to whatever. So it's always this kind of connection between minerals and biological systems and these kind of things. So electrical ecologies, where does it come from? So I thought, like, instead of just putting dark ecologies or black ecologies, I mean, one was by Timothy Morton, one was coined by Hayek as well, is that, okay, like that's cool, but that doesn't really allow us to do much. What I'm proposing is electrical ecologies, which is technically dark ecologies in action, in the sense of, okay, everything in nature, fine, but we need a theory that probably puts, like is more operational, so it allows us to do things. And my idea is that the way to do things more, like to produce intelligence, we need to tweak things at the electrical layer, because that's
Okay.
the layer that is kind of connecting everything from charged objects, electrical objects, to neural objects, the layer that connects them both. So I actually wrote a paper back then which says like, um, all neural ecologies are electrical ecologies, but then not all electrical ecologies are neural ecologies. I even forgot what I wrote. But the idea is that not all electrical ecologies are neural ecologies yet. Like not all electrical objects are neural yet. And what we wanted to do is to make everything neural, right? That's the again, like the end game. So making everything neural producing more intelligences, making more things connected, creating what we call like the planetary scale nervous system, making all these kind of things integrated, having collaborative intelligences, and so on. So that's where electrical ecologies, the brain implant thing come together.
Yeah. So now from there, we can lead into kind of like your research that it's pretty much like try to, I guess, like form a way to connect between like urban or architecture into like directly your brain scan, right? Or forming that connection into like how you perceive the exterior and how that gets captured in some data, but that is being I guess generated by your brain, right? So talk a little bit about like what you're researching in that space. I say to you jokingly, like you're doing neural architecture. So talk a little bit about that. Yeah.
So this has two parts. The first part is understanding the impact the environment, like the built environment, has on your brain, right?
Yeah.
Or on your experience in general. But we can even trace that to the impact on the physical brain itself.
Mm-hmm.
Okay. So but then why that is interesting is that because you say, okay, but how do I measure the impact of the built environment on the brain, right? So the first thing that was my first intuition, which is, okay, to do that, we need both things to speak the same language. And for this, we need to kind of quantify both because otherwise we cannot have like any linking. So then the question becomes, how do you quantify the user experience or the human experience, the architectural experience, if you want to call it? And then how do you quantify the environment? So then you come with two things, one called human metrics and one called spatial metrics. And then if you manage to kind of, get sensors enough to measure both, right? And in our case, I was using 14 sensors. So from the body, I was measuring heart rate variability, skin conductance, brain waves, brain activity. What else was I measuring? Yeah, body temperature as well. And then from the environment, I was measuring like things like ceiling height, because from the literature, we know that that probably affects that, right? The ambient color, the amount of noise, the amount of greenery. You start to one at a time and then quantify things. And then we were doing literally correlation analysis to link both.
Mm-hmm.
So here we start to have like a bit of an idea on, okay, now we understand how some of the features of an urban environment, how they can affect your brain, how they affect your experience. Probably, you know, you do some experiments again where you don't have these metrics and then you see how they impact as well. So that's the first part, which is truly trying to understand the impact of the built environment on your architectural experience. And then once you understand that, you start to have these connections between, okay, this thing promotes this kind of stuff. This thing promotes this thing depresses that, whatever. And then we start to propose designs that are actually informed by these experiments and by that research, right?
Okay.
And then why this is interesting is for two things, right? I have been within this space for quite some time, and there's something that comes all the time and gets on my nerves, which is when people say like the literature says whatever, and then
Yeah.
like the literature means there was one guy sitting in at best in a lab 80 years ago, right? Trying to understand something without having all the tools and the sensors to actually measure that. And then he came with some conclusions. And then you have people today which says like from the literature, right? We can know that whatever red color makes you more happy. And then it's like, guys, we have some sensors that you can just put on and go inside and just like check it, right?
Mm-hmm.
So we should abandon this thing called from the literature. What we should get from the literature is the questions we need to answer and validate with technology today. And that's exactly what we're doing. So from the literature, we know that ceiling height would affect your kind of experience. Different colors would affect that. Presence of light, presence of water, presence of vegetation, noise levels, and so on. But then we get our tech stuff, and then we do experiments and we validate these things, right? So
Yeah.
that's why we do that. But then the second thing is, because once you start using technology, you have two things that emerge, right? One is a common language with other people. So when I started to do this research, I was thinking I was doing neuroscience.
Mm-hmm.
And then it took me a year and a half to discover that I was doing neurotechnology because I had no idea about neuroscience. right? But I had some Arduino knowledge and some programming knowledge, and then that put me on a like a kind of an equal plane as someone who is like a computational neuroscientist or a neurotechnologist, right? Because now we all speak technology. So
Hmm.
technology was the place where a neuroscientist and computational neuroscientist, an architect, an urbanist can connect, because if we know how to speak that language, that becomes the knot, right? So that is important. And then the other place, which is we are producing architecture now in a very digital way. And then if we manage to do these research, like these research experiments, and then these research tools, such as like the wearable I was developing, then we can actually integrate design processes that are directly embedded within this. So, for example,
Hmm.
once I do some research and I understand how some features can impact my experience in a patient unit in a hospital, right? Then what we did here was using feedback from the users directly to inform the design process, which was generated using AI. And then if you're doing things from the literature, you cannot do that. You know, it's that simple.
Yeah.
So it's mainly these kind of these kind of things.
So talk a little, because I thought that was really interesting, and you had shown me like that the sort of like feedback loop between
Mhm.
what I guess like somebody at a hospital would see, and how you can use essentially generative models that take as input that biofeedback, and
Yeah,
then be able to capture that and regenerate or generate some adaptation based on the feedback. So talk a little about that kind of like loop, because that's essentially like that's kind of what you're aiming at, right? You want to be able to then take data from like humans in a more direct way from the brain, and then be able to use that to essentially, I guess, like design, or like to be able to generate spaces that are now you can verify that they're affecting humans in some biological way.
definitely. So I mean, let's start from like a lot of years ago, where we all
Yeah.
had these ideas, reading a lot of like old architects thing. I mean, which are ideas that have like shaped a lot of what we're doing, which is having autonomous architecture, autonomous spaces, spaces that are responsive, spaces that behave, spaces that move around, spaces that have brains, right? And like all these kind of stuff. But then if you think about like, but how you do that, right? This means that buildings need to have brains, and building need to be responsive, and then they need to access your brain as well, and then have this kind of communication between both. Because the idea is this. It comes from an idea called bidirectional mutation. So you have a mutation of space and a mutation of brain at the same time. You can take it all the way to, okay, they both occur simultaneously, right? And then you can take it, okay, like they're both impacting each other. We're fine with both. So
Hmm.
if you think about it in the sense of a riverbank, right? So let's imagine a river, which is like literally earth with water, right? So the physical form of the earth channel that you have, usually rivers like go in curves. Um, if you think about this physical riverbed, the physical riverbed is shaped by how the water flows, right? And
Hmm.
then the water flows based on how the river is shaped. So these two things are always in this kind of bidirectional mutation as well. So you can think about the architectural experience and the physical brain like the same. So these two things
Hmm.
impact each other. And that's why if you enter a space for the first time, you have one experience. If you enter it for 1,000 times, you have a different experience,
Hmm.
because we have like our perceptual sets kind of, okay, now I get it. Now it's like not impressive anymore, right? And this is because actual experiences impact your brain directly. So that being
Do you
said,
mean like the expectations, like that your brain, like, because we are like, I guess, like I would say like we're our pattern seeking machines, right? Like our brains are
we
kind of
are
always looking for patterns. So that expectation gets essentially built in
for sure,
space, kind
because
of.
I'm
Yeah.
sure this happened to you. Like if you go in a city from one place to the other the first time, it feels
Yeah.
much longer than if you go for 10 times.
Yeah. Yeah.
Yeah, because the first time you have a lot of new things that your brain is unlocking, and then every new thing feels like a lot of, like there's a lot of stuff happening. So that's why the journey feels very long. But then if
Mhm.
you go there every day, it becomes super fast, because now your brain already knows all this stuff.
Yeah. Yeah.
Yeah, but yeah, so that's the idea. So for me, what I was trying to do is, that's what we were calling it before, is like responsive spatial behaviors based on the human unconscious, in the sense of I I'm fan of when spaces respond to us without us actually asking them what to do, than us kind of controlling things. So I would like, okay, this has happened to all of us. You're entering a store, and then the door opens. Great. But then sometimes you're just passing by a store and the door opens. It's like nobody asked you to open, right?
Yeah.
So if that door was connected to your brain, it would know that your direction patterning would be going that way, and then probably it won't open, right? That's like a very silly example. But I'm always trying to understand of how environments can actually connect to us, and then have both the humans and the buildings at the same kind of footprint, where they both interact, and then the
Hmm.
buildings or the environments or the spaces, whether virtual or real, right, kind of change, and then this change will automatically impact us, and so on and so forth. So it's like kind of a living together in one ecology.
Yeah. And I think what's really interesting, or like the whole idea of like a smart building, is that it's able to have all these sensors essentially, and the building
So
would auto-regulate itself.
yeah, so the problem with the word smart is that nobody knows what it means.
Oh yeah.
Nobody knows what smart as a word means. So that's why we use it like intelligent building, intelligence, spatial intelligence, artificial
Yeah.
intelligence, because at least we kind of have an idea what's that. But like smart is just, I mean, yeah, sure.
Yeah. So Firàs, and then like we're coming up to the hour, but to close it up, because I think like the neural topic is really interesting, and I see that you're kind of like pushing that direction, and you're now testing it with generative models, and there's been recent developments that you're probably aware of, like Neuralink, or being able to take
Oops.
like EEG scans, and then using like stable diffusion or one of these like image models to translate like those signals into like a visual image.
Where are
What
they?
what do you think about, yeah, can you talk maybe a little bit about that, and like where you see this kind of going essentially, or what you're essentially would like to see in the future for this in architecture?
Yeah, so okay, we don't have much time. So the thing is, uh, I think that this is going to first be for the very serious and the very unserious. So
Yeah.
brain implants are going to come for very complex medical solutions, right? Where people cannot move, or people cannot speak, or cannot see, whatever, like very serious stuff. But then they're going to come for very silly stuff like entertainment as well.
Mm.
Um, that's my speculation. We'll see what happens. So what this means, because people are, in general, people are bored, and when people are bored they usually have some money, and then when people are bored and have money they do silly things, and that's where, a lot of the markets that we live today are driven by literally that.
Yeah.
So that's where I see things like Neuralink or all these technologies coming in. So for people who probably are not in the space, there are like several types of ways to interface with your brain. Some of them are like invasive, where like you have electrodes going inside your brain and skull, right? And then others are just on the skull, and then others are just outside, like we just put an electrode here, right?
Hmm.
And then the issue with that is that resolution is very complicated. So if you're measuring data from a non-invasive device, even if it's very, very precise, it still gets you to a lot of stuff, right? But it's definitely not very precise as if you're measuring directly, like with an electrode inside, right? And then there's a difference there between reading from the brain and then writing back to the brain.
Hmm.
Because what things like Neuralink allows, that we are now having the brain as the read write, not just read. Because for the last, like since the beginning, like since for the last 100 years, we were able to read from the brain somehow. But the issue was always how to write back to the brain. So
Oh
of
yeah.
course now there's a lot of systems which are doing like transcranial simulations and so on and so forth. But there's nothing that beats actually stimulating like inside the brain.
Mm.
And that's where the revolution is coming in, because when you start to be able to read from the brain and write at the same time, then you can actually impact how people are feeling. You can move a hand. You can literally move someone's hands using a remote control, and this is something that has been done like 10 years ago. But as well, you can have people like drive drones and do stuff right straight from the thing, and it's not very far away. Like I was doing some research on this, and you'd be surprised to see the amount of people today that have implants for just basic stuff like unlocking their entry to the office and unlocking their car and then credit card stuff, whatever. So people are kind of slowly becoming more ready to do this. And I think in a more um, dark way, let's call it,
Yeah,
it's
dark
gonna
mirror.
no, it's gonna come. It's gonna come with a question of health and security always.
Mm,
That's how I think things usually evolve. And then it's gonna be like, okay, you're gonna have an implant that will allow us to monitor your health 24/7, and that will preventing you from having cancer, from having like all these disease, whatever, because you're gonna have the notice much before. This can allow you to avoid seizures, all that kind of stuff. And then if you ask someone like, would you put an implant and not have all these, or not put an implant and then have these? Probably they will choose to have an implant and not have these, right?
yeah.
And then once people have this interface, the number of things you can do there is just infinite, literally. There's going to be like different markets for different resolutions, how much you're in. Then you're going to have some antiviruses for these interfaces as well, and then you're going to have like, of course, like different applications that are connected by different implants and so on and so forth. It's super exciting. The juncture where what excites me the most is the connection between this kind of like implant interfaces, AI, and spatial production. So when we start to combine these three, that's where things for me become very, very exciting. I think we're a bit too early for sure,
Yeah.
because again, like imagine you have, and by the way, like one thing that usually people refer to when they talk about metaverse is that okay, it's virtual, it's online, it's whatever. But as well, I think there's a huge chunk of the metaverse that's going to come in the form of augmented reality.
Hmm.
And my speculation would be probably that AR will take over mass adoption before VR.
Yeah.
And when that happens, you're going to have kind of real time, metaverse in actual physical life. Right, and then if you're wearing these glasses, probably they will have some neural interfacing because now there's EEG interfaces in headphones, in earbuds, in things you put on your neck, so on and so forth. And then this is called the everyday EEG revolution as well, like for people who want to
Mm.
look at stuff. Um, so yeah, when you start to combine all these things and put this in real life, that's going to be really, really, really exciting. I'm working with a student now within the cluster where we're trying to improve office environments based on your performance metrics from EEG, right? So you have a
Oh,
person
interesting.
sitting in an open office environment. They're sitting on their computer and they're typing, right?
Yeah.
Um, Within that device, you have like sensors that are monitoring your mental metrics, your performance
Yeah.
metrics as well. And then if you're probably, let's say, a bit stressed and you're wearing these glasses, then it just kind of dims down all the lights and then makes the environment more bluish or more greenish or whatever. If you feel like if your performance metrics start to tell us that you're a bit bored, right, then some things start to happen. Students working on biophilic design, so she's working on biophilic features, like some plants will start to grow next to you, right? And then obviously this is still a prototype stage, but all these applications is where I think the value could be, where you connect real life applications, augmented reality, and then EEG and AI to be the generative system there, right?
Yeah, that's so cool. It's almost like we're now like either by connecting to all these things like biologically, using like AI and so on and so forth, we're building like this extra layer now of like reality that is gonna be like accessible in that manner, like augmented reality. Like Meta has like the Ray-Bans glasses now, where they're trying to
Dude,
like
there were
talk
a
to
lot.
the
Like
LLM.
there was a Hong Kong based guy on Kickstarter. Literally, he closed it 3 weeks ago.
Yeah,
He was doing something very similar, but there was no EEG. It was just AI AR glasses, like smart AR glasses,
yeah,
where you'd literally say like, "Hey, take me there," and then it automatically just gets the thing, show the maps, and then steers your way there if you're on the bike, right? And then it's like,
Yeah, yeah.
hey, remind me tomorrow at 8 morning, whatever. And then it remembers, puts on the calendar, and then you have it. So this kind of AI assistant inside an AR glasses is already there.
Yeah, that's fascinating. So, Firas, we're coming up we're pretty much at the hour now. So
Yeah.
I just want to say thank you so much for being a part of this. I really enjoy the conversation. Like I think like from last time we talked, like you're doing like really interesting stuff, and I'm looking forward to see what else you come up with. Like for final words, do you have some final words for like students or advice? Maybe like based on like all the things that you're researching now that you find interesting for students.
Yeah, usually, I think the most valuable thing is active friction. Like literally, just go and do it. That's all. Like
Yeah.
just do it. Just do it. We as architects are one of these very few generalist domains and professions that really has a lot of value if you take it the right way. We know a lot of tools. We know a lot of ideas. We know a lot of things. So I think the best advice that anybody could have given anyone is just like go for it, do it, get into it, get your hands dirty, and start doing things. Right. Um, that's on one side for sure. And then the other thing that I'm now coming to, which is like one advice from Peter Eisenman, which is learn the language, right? And he says like Donald Trump became the president of the United States because he masters the language of media. And then
Mm.
like master whatever language you want. Master Python, master love, master architecture, master
Yeah.
media. No, seriously, but the moment you kind of master any language, even if it's your own, that's where you become the guy, right? You become the
Mm.
person. And I think if you can combine both, which is master a language and then go do stuff and get your hands dirty, you'll be fine.
Awesome. Great words to finish that on. Again, thank you, Frida, so much. This was really enjoyable, and I'm like learned a lot. I always learn a lot speaking
Thanks,
from you
man.
about like what's going on in that space. It's kind of fascinating. So thank you again, and yeah, we'll hope to see what you end up doing, and we'll catch up some other time.
Cheers. I mean, it's a pity we just had an hour, but keep doing what you're doing, man. I think I love
Yeah.
what you're doing as well.
Yeah, cool. Yeah, maybe next time we'll like get like an actual demo of you doing some like the
Sure, that'll be
neurotech
fun.
stuff.
Yeah,
Yeah, that'll be
that'll
cool.
be
Yeah,
fun.
we'll figure it out. Cool. All right, guys. So thank you again for watching this. We were live with Fidas today. Follow him on socials. We left the links, and see you on next time. See you,
Cheers.
Fidas. Cheers.
Are we still streaming?